We are literally in hell and about 40 light years away from Earth in the constellation of Cancer. This planet is the world of extremes. Prepare to be amazed by the story of 55 Cancri E, a super hot super Earth that defies all our expectations. And stay tuned as we uncover the secrets of this magnificent planet. Don't forget to like and subscribe for more cosmic adventures. Let's begin our exploration of 55 Cancri E. So this is the night sky, and in order to find this magnificent planet you must find the Cancer constellation first. Note that Cancer constellation can be seen from September to June. Here we are in February and you can see it up in the sky. Let me find it, and here, Cancer. You can see it up in the sky, and let me turn on the constellation art, and here it is. So the planet that we want to talk about is here. It resides here in the constellation of Cancer. By the way, leave a comment and express your opinion about aliens. Do you believe in them? Do you believe that somewhere in the sky and somewhere maybe in a different constellation there's a planet that in the surface of this planet there are so many aliens growing, studying, and maybe observing us? Do you believe in them? Leave a comment. Here we have 55 Cancri E and its parent star. You can see how big it is. And 55 Cancri E is a planet that is called a super Earth. It is an exoplanet that is called super Earth. And what does it mean? A super Earth is an exoplanet that is more massive than our Earth, but significantly lighter than some gas giants like Neptune and Uranus in our solar system. So it is called super Earth just because it is more massive. It can be composed of gas, rock, or maybe the combination of both. So when we say super Earth, it doesn't mean that it is necessarily similar to Earth. It just means that this super Earth is more massive than our Earth. So maybe there is life in it, maybe there is not. In case of 55 Cancri E, it is a lava world. It means that it is filled with lava. Super Earths are very important to us because they occupy a size range that doesn't exist in our solar system. I mean, we don't have any super Earth in our solar system. So by observing these type of planets like 55 Cancri E, we can gather so much data about their formation. Okay, let's explore the system of 55 Cancri. You can see that there are other exoplanets as well, like 55 Cancri F, 55 Cancri D, and 55 Cancri E. You can see how close it is to its star. And 55 Cancri E is also tidally locked. It means that the time it takes to rotate on its axis is as the same as the time it takes for it to complete one orbit around its sun. So as a result, one side of the planet, I mean 55 Cancri E, always faces the star. So we have a permanent daylight, and one side of the planet is in a constant darkness. How did the astronomers find this planet? They used a method called transit. Transit is a very straightforward method, and in order to find out what it means, you can imagine that you're watching a distant street light through a window. Now picture a bird flying across the window. It's briefly blocking some of the light. So you notice the light dims slightly as the bird passes by. So in a similar way, the transit method, as you can see here, looks for distant planets, I mean exoplanets, as they pass in front of their stars from our point of view. Look at here, when this happens, I mean when the exoplanet passes in front of their stars from our point of view, it blocks a tiny portion of the star's light, causing a small temporary dip in the star's brightness. You can see it here, a temporary dip in the star's brightness. So as you can see, we can now confirm that there is an exoplanet passing in front of the star, and blocking a portion of its light. By this method, astronomers can confirm the exoplanet, and they can also confirm its orbit and the size of this exoplanet. Now, let's see the system again, because I want to tell you something. You can see the system from here, and this is called a habitable zone. It means that when the planet is in this place, it is in a suitable place from its star, it is in a suitable distance from the star, that it can have some water in it, maybe it can have aliens life in it. I told you how close it is to its parent star, but you should know that 55 Cancri E completes one orbit around its star in around less than 18 hours. It means less than a day compared to our solar system. In our solar system, we have a planet called Mercury. It is so close to our star Sun that it completes one orbit in around 88 days. So 55 Cancri E just complete one orbit in around 18 hours, less than a day, so which is insane. Now let's compare this exoplanet. You can see how big it is compared to our Earth, and you can see also that how small it is compared to our Jupiter, our interesting gas giant in the solar system. So let's do something interesting. Let's explore the surface of 55 Cancri. Here you can gather so many data about this exoplanet. You can see its star. 55 Cancri E orbits a G-type star named Copernicus, and it is slightly smaller than our Sun. And the planet is 65 times closer to the star than the Earth is to the Sun. So the star would appear 65 times bigger in the sky than the Sun appears to us. You can see here that we have the day side, and here we have the night side. So the day side lava, as you can see, although the planet is covered in a global lava ocean, the lava facing the star is significantly hotter. So obviously, and here we have the night side lava. Astronomers using James Webb Space Telescope detected some atmospheric gases surrounding this exoplanet, which is insane because this planet is so close to its star that the star should destroy all the atmospheric gases around this exoplanet, right? So why there are so many atmospheric gases around this planet that James Webb Space Telescope detected? We don't know, but it is very useful for us because with James Webb Space Telescope we can see how the planet formation works in other places than our solar system. So that's it. Thank you for watching. Stay curious and bye.